Hi, hello. So welcome back to my YouTube channel. I am welcoming you for one more interesting video, that is question number 2161 lead code problem statement. So in this video I will be discussing question number 2161 problem statement, which is partitioning array into according to the given pivot. After that I will explain the problem statement along with some test cases for better understanding of problem statement, and then followed by logic explanation, and finally I will explain the code for that problem statement. So without further gets delay, let us move on to the problem statement explanation. Yes, let's see the problem statement. So you are given a zero indexed integer array nums. Here you will be given an integer array nums and one more integer called pivot. Here pivot is single element, whereas nums is array. Okay, rearrange nums array such that the following condition satisfied. Okay, we have to rearrange the elements of array by following the following conditions. So first condition is what? Every element less than pivot appears before the pivot. It means that to the left of this pivot element we have to keep all the smaller values who are less than this pivot element to the left side. Okay, and every greater than pivot appears after the pivot. It means what? All the greater values for pivot should be right side to the pivot element. Okay, and every element equal to pivot appears between the elements less than and greater than the pivot. It means between the smaller values, between the larger values, all the pivot elements should appear. Okay, next fourth point is the relative order of the elements less than pivot and the elements greater than pivot is maintained. Okay, the relative order also you have to maintain while rearranging the elements of nums1. So this is the 4 points that we have to satisfy while rearranging the elements of the array nums. Okay, for better understanding of the problem statement, let us see the first test case. Here my array is 9, 12, 5, 10, 14, 3, 10 and my pivot element is 10. Now let us see what is the expected output for these inputs. Okay, right. So here first thing, what is the problem, what are the conditions here? Every element, so let me mark the first condition. So what is the first condition here? Every element less than pivot should appear before the pivot. Okay, here pivot is 10, right? So here what are the elements less than 10? Pivot element 10 here, 9, 5, 3. So here all these smaller values which are less than pivot element should appear before the pivot, means left side, and over the greater values for this pivot, greater than pivot values are what? 12 and 14. They should appear after the pivot, right? So that means what? 12 and 14 will come right side, and over the pivot elements finally 10 and 10. We have two pivot elements, and these two pivot elements we have to keep between the smaller and larger values. So it means that this 10 and 10 will appear between the left values and right value. It means that in the middle you will get the 10, 10. So this is the expected output. This is the correct rearrangement as per the given conditions. Okay, so this is the expected output for test case 1, right? So observe carefully what is I am doing. Pivot elements are coming here, and to this pivot element all the left side values are greater than this, less than this pivot element, and all the right side values are greater than this pivot elements, and all the pivot elements should come between these greater and lesser values. So I hope you understood what I am explaining. So I hope you understood this test case 1. So this is the problem statement. For better understanding, let us see one more test case here. So here pivot element is 2, means the left side values to this pivot element should be smaller, right? So that is -3 will come to the left side, and -3 is over, and over the greater values 4 and 3 are the greater values for pivot elements, so they should come right side. And here you can see the relative order I am not changing. I am writing 4, 3, not 3, 4. The relative order also you have to maintain as far as given input. Okay, so the whatever the order is there in the input, the same order you have to follow while rearranging, right? Now, so over the pivot element 2, so 2 we have to keep between this less than values and greater than values. So this is the expected output for test case 2. So I hope you understand it. So if you understood the problem statement clearly, then try to do yourself, otherwise without further gets delay, let us dive into the logic explanation. Yes, let us see the logic explanation. So first, my intuition is I will select the smaller values than pivot. Okay, I will select the smaller values than pivot. So those values I will keep left side of the another array. I am taking one extra array here, and I will select next. I will select all the larger values than pivot. I will keep all those values right side of this result array, and in between I am going to keep all the pivot values. Okay, so this is my intuition here. Let's see how to do this effectively. Okay, so to do that, what I am doing is I am taking one pointer here, I variable, and one more variable called j variable. So here I variable I am taking it to 0, and j variable initially I am make it to 9. Okay, right now. So here one more variable I am taking called left and right. Okay, so left variable pointer I am taking to keep smallest value left side. Here left is index value, and I am taking one more variable called right. I am keeping this right value to the I am keeping this right pointer to keep the larger values right side. Okay, right. So here let's do this. So here what is my nums of I value here? What is my nums of I? It is 14. Is it smaller value than pivot? No. So once this nums of I is not smaller than pivot, simply you have to shift this position. You have to shift this I position to the next position. Okay, understanding, right? So what is my next I position? It is 1, because 14 is not smaller value to this pivot value, right? So that's why don't do any action, just increment the I value by 1. Okay, so I'm writing condition also here. So whenever nums of I is less than pivot. Okay, let us see if nums of I value is less than pivot means let us see what to do. Okay, but actually 14 is not smaller than pivot, so don't do any action here, simply increment the next I value. Okay, right. The same way go to the j. So nums of j is what? 10. Is 10 is greater than pivot here? No, greater than. It is not larger value, so don't do any action here, so decrement the j value by 1, right? So for this also I'm writing condition below, just see this, right? So here nums of j is greater than pivot, right? But nums of j is not greater than pivot, right? Here 10 is not greater than 10, right? So that's why don't do any action, just decrement the j value by 1. So that's why my j value came to index value 8, right? So repeat the same task here. So repeat the same two conditions here. So repeat the first condition again. Okay, right. So what is nums of I this time? 10. So 10 is less than 10? No. So means don't keep the 10 value in the result array, right? So just move on to the next I value. So what is the next I value here? That is not, that will be index value 2, right? Now, and again come to next condition. Nums of j this time 10. So 10 is not greater than pivot 10, right? So move on to next j value, that is decrementation of j. Okay, now so move on to next j value. So this is next j value. Okay, alright. So again do these two conditions here. So what is nums of I here? So nums of I is 5. Observe carefully this time. So nums of I is 5 less than pivot is 10. So this time nums of I is smaller value than pivot. So simply this 5 you have to place to the left of this result array. It means that at left index you have to keep this 5 in the result array, right? So once this condition is true, so what I am doing is from nums array position, from nums I position, we have to keep that value in the result of left position, right? So if this condition is true, what you have to do is result of left is equal to nums of I. Result of left is equal to nums of I you have to keep, right? So it means from nums of I you have to keep that value in the result array at the left side. Okay, now again after keeping that, increment the left pointer by 1, because next small value, the next coming small value you have to keep it index value 1. So that's why after keeping the smaller value left side, increment the left pointer by 1. So left pointer you have to increment by 1, right? So if this condition is true, so move on to the next right side part, that is nums of j. Second condition, nums of j is 3. Is 3 is greater than pivot? No. So absolutely wrong condition. So decrement the j value here. So what is j value now? So j is 6, right? J is index value 6. So repeat the same two conditions here. So this time what is nums of I here? Sorry, I also we have to increment. So forgot to increment the I value. So what is I value now? It is 3. Okay, I value index value 3. Now move on to nums of I. Nums of I is what? 18. Is 18 is smaller than pivot? No. So simply increment the I value here. Next j. So nums of j is what? 2. 2 is greater than pivot element here? No. So simply decrement the j by 1, right? So j will be 5, right? So again to repeat the same steps here. Nums of I is 9 and pivot is 10. So here nums of I is smaller value, right? So here we have to keep, so this time this condition is true. So once this condition is true, then simply keep the smaller value 9 at index value 1 in the result, right? So condition true this time. So nums of I is 9, so keep that 9 in the right side, in the result at left position, right? So 9 will come here, and again left you have to increment by 1, right? So left will be index value 2, right? So this is my left pointer, okay, right? So again increment the I value, right? So here if you observe carefully, in every step I am incrementing the I, but I am incrementing the left whenever that condition is true, right? Now, so next j. So what is the nums of j here? 16. So 16 is greater than pivot? Yes. So 16 is greater than 10. So it is true. So once this is true, the second condition is true. So simply this nums of j 16 we have to keep right side here. So I am writing the statement here. So if the second condition is true, simply in the result right side we have to keep nums of j, right? Nums of j you have to keep. So nums of j is 16, so that you have to keep it index value 9. Next coming larger value you have to keep it index value 8. So for that decrement the right value, right? So right you have to decrement by 1 position. So here so this is my right variable, okay? So after shifting nums of j to right into the result at right position, so for next coming larger value we have to decrement the right pointer, okay, right, and again decrement the j, right? So like that we have to repeat the process, okay, right? So here j will be 4 and I is 6 at index value 5. So we have to repeat this process until this I reach to index value 9 and j reach to index value 0, right? So after doing this, so I will tell you final steps, so you can do yourself also. So here 2 will come, 3 will come, right? And finally left will be at index value 4, okay, right? Now and here after 9 18 will come here, and 14 will come here, and this right pointer will come to at index value 6, okay, right? At index value 6 this right pointer will come, right? Now so once this process is over, once this j reach to 14, like I mean j reach to -1 and I reach it to after 10, means after I reach it to 10, index value 10, okay? So it means that we will stop the process here. So once j reach it to -1 and I reach it to above the last element, means all elements we processed, then still some places are empty in the result array. So these places we have to occupy with the pivot value. Here how many pivot values are there? Here pivot is 10. How many values? 10 are there, 3 are there, means these 3 10s we have to keep in this 3 empty places. So how we can make is, once this I reach it to after the last element and j reach it to before the first element, so what you have to do is check whether left is less than right or not, okay? Check whether left is less than or equal to right or not. Here what is my left here? 4, and what is my right here? 6. Is left is less than right here? Yes. Whenever this condition is true, simply at left position we have to keep the pivot value 10, right? So simply what I will do is, whenever this condition is true, then in the result array at left position we have to keep a pivot value, right? So here 10 will come. Next pivot we have to keep it here, right? So for that I will increment the left pointer, okay? So once this pivot is inserted, then simply increment the left pointer by 1, okay, right? So here next left will be index value 5, right? Okay, so my left pointer is 5. Here this is the final step actually. Here what I am doing, all the remaining 3 places we have to fill it with left pointer, yes or no, right? Now so left is 5, so here left is 5 and still right is 6, so left is less than right only, so still this is true. So again we have to keep 10 here, and again we have to shift our left pointer to next position, right here. So here left is now index value 6, right also index value 6, both are same. Even the both are same, these are true. Whenever true, then again keep pivot at index value left and again increment the left. So now left will become index value 7, but right is still 6. Now left and right both are left is not smaller than right this time, because left is exceeded the right. Now we will stop the process here. So if you observe carefully, finally I did my operation. My operation is what? All small elements are I inserted left side, and all the larger values I inserted right side, and all the pivot elements I inserted in between the smaller and larger value. So I hope you understood the logic explanation. Let us see the code part. So this is the code. Let us see this code. Okay, initially take total number of elements here. For our example, n is 10 elements I have taken. So here I initially 0 and j will be initially 9, that is last position, that is n minus 1, and take one extra array, result array, and that size also same as the original array n. So left pointer also keep n, and right pointer also same as j, that is n minus 1. So this condition I already explained, right? If nums of I smaller value than pivot, then simply that nums of I have to keep left side to this result and increment the left. And if right side, that is nums of j is greater than pivot, then keep that larger value right side and decrement the right. So irrespective of these two conditions, I and j, I have to increment, j we have to decrement. As in that process we have to repeat until I is less than n and j is greater than up to 0, right? So j you have to decrement up to 0 and I we have to increment up to n, right? Once this is over, then the remaining portion is what? In the result array, in the middle we have to keep pivot elements, right? So for that I am writing this while loop. This while loop also explained, right? So if left is less than right, then at a left position you have to keep this pivot and increment the left. So you have to repeat this process until left is exceeded the right. So once this loop also executed, finally all the pivot, here we have 3 pivot elements 10s here, so 3 10s are inserted here. Finally smaller values will be left side, larger values will be right side, and all the pivots will be in the middle. So finally return that result. So I hope you understood this code also. So we will meet in the next video. So until then, keep watching my videos and do subscribe.